A single coil of area 0.4 meters squared is placed in a 0.2 Tesla magnetic field. Find the flux through the coil in these different configurations. So in A, we have a coil that's parallel to the field, so the flux is going to be 0. We can see that, right? This direction is the same as the direction of the magnetic field. So if we were to find the flux, we'd take the sine of 0, because that's the angle between it, and sine of 0 is of course 0. Remember that the equation for flux is simply B A sine theta. So in this, we haven't actually used the area or the magnetic field strength yet. So those, of course, must be part of sections B and C of this question. So in B, we've lifted the coil up a little bit, and now it's at 45 degrees to the magnetic field, right? So what's our equation? Flux is phi equals BA times sine theta. In this case, theta is going to be 45 degrees. So sine theta will be 2 to the power of minus a half, if you know your trigonometric identities. B is given to us in the question, and A is given to us in the question, so we can substitute those in. This, of course, will evaluate to be 0.057 Webers. You can also say Tesla meters squared, because that's what we get when we multiply the units of magnetic field by the units of area. It's a fairly useful conversion factor. 1 Weber equals 1 Tesla meters squared. Alright, on to part C. And in this case, we will have the maximum flux. So what's our angle theta in this case? Well, it's going to be 90 degrees. And the sine of 90 degrees is going to be its maximum value, 1. So in this case, our flux is just phi equals BA, and we can ignore the sine theta. Substituting in our numbers, 0.2 and 0.4, we end up with a flux of 0.08 Webers.